Hello there, it's Coding Jerk. This channel started with a review on a Zig release, so I guess it's my duty to keep doing that. Sorry for being late with this one. This video was the hardest one to make thus far, mostly due to non-technical reasons. Anyways, between 0.14 and 0.15, Zig received a lot of changes, so let's talk about them. First, this patch is quite big. Here's the too long didn't watch version for busy people who just want to keep up with Zig's evolution. Starting off with the compiler changes, the LLVM-free self-hosted backend for x86 is enabled by default, and debug builds are now up to 5 times faster. Threaded codegen has improved, giving another speed up to 50%. Zig init now has a new default template and an optional minimal one. And there's now a web interface for the build system with Zig Build Web UI. Then the language changes. The async and await keywords were removed, and they will not be back. We may get low-level stack list coroutines in the future. See the detailed section for more. Switch is now allowed for non-exhaustive enums. The using namespace keyword was removed. I wasn't a big fan of it anyways, but we will check out use cases and how to replace them later. More operations are now allowed on bool vectors. Clobbers and inline assembly are now properly typed. @pointer cast can now cast single item pointers to byte slices. Arithmetic on undefined is now safer, and lossy int-to-float casts are now compile time errors. And for the biggest part of this update, the standard library changes. So first off, we're going to talk about Writergate. Reader and writer interfaces are getting reworked like allocators were in the past. They are now non-generic, more flexible, and easier to use. We'll talk more about Writergate, its consequences, and examples later. Standard ArrayList is now unmanaged by default, meaning it doesn't store its allocator inside. HTTP client and server were reworked. Formatting got a lot of medium-sized changes, more about them later. Standard progress now supports bar escape codes. I didn't even know these existed. Many of the ring buffer implementations were removed. And yeah, also on the topic of deprecations, renames, and removals, BoundedArray has been removed. Standard FS file reader and writer are deprecated. A lot of standard format functions should be used as format specifiers, and much more. The full list is on the screen right now. Finally, here are the future plans and or the stuff that's work in progress right now. ARch64 self-hosted backend, ditching the LLVM linker and finishing incremental compilation, moving all input, output, and other related operations, basically everything that can block, into a separate I/O interface to allow abstracting concurrency models. This is also a huge and promising long-term project for which I recommend watching Andrew's talk, and improving the built-in fuzzer to compete with SOTA solutions. To end off the TLDW, even the summary version is pretty long, but for true Zig enjoyers, here are the details on the changes and my opinions. But before we start, a quick announcement. I'm giving away 5 copies of Hollow Knight Silksong to show appreciation to the community and at the same time to help the developers of this amazing game. So if you're a fan or just interested, send me a DM on Discord. My username is the same as everywhere, Coding Jerk in one word. There are no entry requirements. You don't have to subscribe or write a comment or anything, even though I would appreciate a lot. You just have to message me. Yeah, I'll be waiting for your messages, and I hope my DMs can handle it. Good luck. Okay, back to Zig. Let's start with compiler changes. So for those who don't know, compilers nowadays don't directly generate machine code because it's a pretty hard job to support a million different architectures like CPUs, OSs, etc. Instead, most of them use LLVM, a library that does all of that based on its own machine-independent assembly-like language called LLVM-IR. This approach has many advantages, such as less work for compiler developers and better optimizations available to them for free, but it also has some disadvantages. For Zig, it specifically means slow compile times. So for debug builds, the Zig team decided to write their own self-hosted, aka LLVM-free backend, and in this release, it's finally done for at least the x86 architecture, except for on Windows and OpenBSD. This change alone gives up to 5 times faster builds and opens the door for even more improvements in the future, like incremental compilation, which is still a work in progress. It also speeds up so-called check builds, where we add this flag to not generate any artifacts, but run every other compiler step just to check for syntax and typing errors. So we're getting a much better developer experience already with even more to come. And if you want to use the LLVM backend because of the bugs with the self-hosted one or for debugging, you can still do that with this flag. Release builds still use the LLVM backend because it generates faster code. The next step by the Zig team is finishing the AR64 self-hosted backend, which passed 84% of the tests at the time of this release. Continuing on with speedups, parallel compilation has improved, allowing work to be split into multiple threads for semantic analysis to code generation, giving up to another 50% speedup. With all of that, the Zig compiler itself compiles in just 10 seconds from scratch, using the self-hosted backend in debug mode. But the Zig team is not stopping there. Currently, they are working on incremental compilation, which is still a work in progress and not enabled by default for this release. In the next release, it should be ready and will allow recompiling only change parts of the codebase, giving even more speedups, especially for big projects. So in turn, maybe recompiling a big project such as Zig itself will take just a few seconds, which is a huge deal for the developer experience. Another change is more control over the UBSAN, or Undefined Behavior Sanitizer. It's a tool that helps find undefined behavior at runtime, and it's very useful for low-level, unsafe languages like Zig. So now you can configure it more granularly, enabling a lightweight part of it with actual UB checks, but without the full UBSAN runtime with error messages and such. This is helpful for lightweight release builds where you still want to catch UB but don't really care about debugging it. Another feature in the build system is the ability to compile tests into separate object files instead of executables, with the zig test_obj command instead of zig test. I'm not sure why you would want to do that, but it's there. Okay, now this is a nice change. For a long time, there has been a zig init command to initialize a new zig project from the template. This version gets a new default template. It's not a big change. For example, build zigzon and build zig files are mostly unchanged, just with some necessary updates. But the source code has been cleaned up a bit, especially in source main zig, which got shorter and imports are finally at the top. But for me personally, the best part of this update is the minimal flag, which creates only build zig and build zigzon files. In my opinion, it should include the bare minimum for an executable project like source main zig with an empty main function and a build script with build, run, and test steps, but whatever. Probably it can be improved later with custom templates or minimal exe and minimal lib flags. Yeah, let's now go to a web interface for the build system. Running build zig with the web UI flag starts a web server with a horrendous UI, but with useful information if we also add the time report flag. Not much to see here now, but we can basically see how Zig compiled 100 source files in just 200 milliseconds, which is pretty impressive and will only improve when we get incremental compilation. Okay, let's talk about language changes. Probably the most important change in this release is the async await removal. Zig developers settled that async await is not how I/O will work in the language in the future, so they will never be back. Instead of colored I/O, Zig will extract all the input-output operations into a separate I/O interface. This way, we could use every function with every I/O execution model. For example, if we have a function depending on sleep, we can use it in blocking or asynchronous code, or use it in any environment, bare metal, WebAssembly, etc. It's not established right now, but it looks very promising, since similar approaches have already been proven to work. Also, stackless coroutines as low-level primitives might remain in the language, but it also might not. I find colorless I/O tempting, but honestly, this means we have to wait even longer until we can finally write async code with ease. Switch with non-exhaustive enums. Another language change, this time to actually allow us to write more code. Check out the following example. It's a simple enum with 3 tags and a switch statement over it. Internally, this enum is represented as values 0, 1, and 2, and all other values are prohibited at compile time, so the enum is exhaustive. But Zig can also have non-exhaustive enums if we add an underscore as the last value. This way, we can still use its tags, but can also pass any other number that fits the underlying type. The problem is, though, before Zig 0.15, it wasn't possible to switch on such enums. But in the latest patch, we can also repeat the same underscore, which will act as a pattern for all unnamed tags. In addition to the underscore, we can use the else branch together with it. It will represent all missing named values. This approach is pretty robust since it allows us to keep the named part exhaustive. For example, if we add another named value to the enum, a switch without an else case, which compiled before, will show us an error that we missed matching on our new tag, even though the switch has an underscore pattern, only for unnamed tags. The next change is the removal of the using namespace keyword. Thanks, I hated it. I'll show you just some examples of how it was used and how to replace it. Look at the following code. Here you have a bunch of simple definitions, but imagine when you want them to be defined only if some condition was met, like the compilation target is Windows, for example. In this case, using namespace allows you to fill the current module namespace with definitions from a struct, which can be selected conditionally, so we will select either this or this structure. The proposed alternative solution to this problem is to just define the variable always. Zig will not compute the value of constants until they are referenced. In case we want to make sure nobody uses definitions which should not be available on some target, we can put a condition with @compileError, like this. Another use case was Mixins. For example, if you have some functionality you want to be able to add to many types in your code. Let's say you have a temperature sensor, like this, and you want to make it observable, i.e. you want its users to be able to subscribe to events and receive them. Since this being observable functionality is not specific to temperature sensors, you want to reuse it for other types too. There are a million ways to implement it in modern languages. In the OOP world, it's most likely inheritance, which in cases when one of the bare cases has just utility functionality, it's called Mixins. Another solution is composition. You can define a separate observable object, and instead of inheriting from it, you can just store it inside your struct, like this. And finally, some languages have proc macros, which allow generating code for your types. For example, in Rust, we could write our observable proc macro and annotate our struct with it like this. In Zig, we can use the composition approach like this. But with using namespace, we could also embed all definitions from the observable mixin into our type. Unfortunately though, since using namespace is removed, we have to either inline the code manually or just use the composition approach. Bool vectors. A little change for vectors of booleans. We can now do bytewise, or more precisely vectorwise operations on them. Not, both bitwise and boolean, not behave the same way, and, or, and XOR, or XOR, I don't know how to say it. Inline assembly cobblers. In inline assembly like this, there is a list of registers at the end. These are cobblers, and this is to explain to the compiler that as a result of execution of this assembly code, these registers could be modified. This is needed for the compiler since it needs to track which registers are used for what to optimize register allocation and keep the program correct. Before Zig 0.15, clobbers were strings like this, and now they are structured like this. So it's easier to get autocomplete here and easier to build cobbler lists programmatically. Another little change is to @pointer cast. It is now allowed to cast a single item pointer to a slice of bytes with the length of the item size, effectively creating a structure like this. Lossy int-to-float conversions. They are now compile time errors. For example, you wrote code like this, defining some floating point variable from an integer literal. The problem is, not every integer can be represented exactly, even not so big ones, and in this case, the number will be affected by representation error. So to make you aware of this problem, Zig now shows a compile time error. To avoid this error, you can specify the number as a float value directly like this. Writergate. Okay, now this one is huge. Reader and writer interfaces, which were basic I/O abstractions in Zig, were reworked, like allocators were in the past. There's a great talk by Andrew Kelly explaining the reasons and advantages of this change in detail, but I'll try my best to give a summary with simple examples. First, let's check how usage of a writer changed with the examples of printing to standard out. Zig is a pretty precise language, so you're in control of most things. This in turn means you will have to control most things. The same goes with printing. You are free to use unbuffered output or use a buffered wrapper to increase the throughput. There are problems with this approach, but first let's check what's changed in 0.15.1. Here we have to allocate the buffer ourselves and pass it to the writer. To use the interface, we'll have to access the interface pointer of the writer, so it's also a bit harder. Now you may feel skeptical about the change, like, yeah, we get more control, but it doesn't look like a better solution, at least in terms of developer experience. But let's check out another example. Here we have a function using the writer interface to send some bytes. Before point 15, we had to use the generic type. A common solution was just to anytype it. And we had to use the imprecise any error in the result too. In point 15, the writer interface is non-generic, and we can now specify the concrete type standard IO writer and the concrete error set standard IO writer error. This is all possible due to a change in the interface definition. Before point 15, it was a pretty complex generic struct with dependencies on the error type, write function, and a context, which is a way for the writer to abstract over the type it's getting included to. Compare with the new interface essentially being a vtable with just a little bit of extra stuff. This change does have some downsides. For one, it's more verbose on the user's end, and usage is harder overall. With every writer, it's now easy to forget to flush. You'll have to keep an eye on the lifetimes of your buffers, like in this example. Returning a writer with a buffer defined on the stack will compile, but result in a dangling pointer error and will do something naughty, probably corrupt your stack. But as in every trade-off, we're getting some advantages too. The most important one is performance. As described in this issue, removing an unoptimizable abstraction allowed up to 2 to 15 times speedup because hop path operations, i.e. write byte, can now work directly with the buffer. No more generic pollution. Consider the following structure containing a writer. It has to be generic over the writer type, and this will propagate everywhere either like this or with any type. The new solution allows us to just keep a pointer. It helps with code generation, tooling, type checking, compile times, clearer error messages, etc. Speaking of errors, it also eliminates any error, allowing precise error handling. It also allows some advanced features like vectorization, zero copyrights, and effective splatting. And finally, at least in this talk, it is better suited for upcoming I/O models. Due to Writergate changes, standard compress.flate also got reworked. Flate is a library for the deflate compression algorithm used in, for example, zip, gzip, and PNG formats. Compression got removed completely because working on it was slowing down changes in the compiler/language itself, and at the moment, language development is the priority. And decompress now requires us to pass the buffer. So instead of this, we should now write this. We got a progress bar! It's a little change, but it's pretty cool if you ask me. As you may know, terminals use special sequences of characters that don't get printed, but instead change some settings of the terminal itself, like color, or move the cursor, or clear the screen, etc. You've probably seen these sequences when your terminal gets messed up, for example, after a program crash or misconfigured output, and they could look like this. Modern terminals support a lot of these sequences called escape codes because they start with the escape character ASCII 27. I knew a bunch of the most used ones, but it turns out there are escape codes to control progress bars. They are specific to ConEmu, a popular Windows terminal emulator, though I didn't find any other terminals supporting them. But the feature itself is pretty cool. I hope other terminals can add support in the future. String formatting, i.e. printing, got a lot of changes too. First of all, it no longer deals with Unicode, so you will have to use it for ASCII strings or find another way to process the Unicode strings, for example, via a third-party library. Then there are changes in format methods. As you may know, in any custom structure enum, you can define a format method which can be used to print the value. So in the previous patch, defining this format method would change the behavior of all printing of the value. Doesn't matter if it's empty braces or the any format specifier or any arbitrary string. Every branch would be processed by this format method with the ability to process the format string and format options. In the current patch, both were removed, meaning now you will have to specify when you want to use the format method with the f specifier. Behavior of the any specifier will not change this time, and the empty braces will result in an error. Another change in formatting is new format specifiers. So we have T for tags and error variants, B64 to show a string as base64 encoding, and D, which isn't new but can now be used with custom integer types via the format number method. And finally, a bunch of functions from standard format were replaced with specifiers. The list is on the screen. Ring buffer cleanup. There were at least 8 different ring buffer implementations in the standard library. Thanks to the Writergate refactoring, many of them became redundant and were removed. Notably, standard ring buffer, standard debug fixed buffer reader, read and write buffers in HTTP client and HTTP server, one in the LZMA implementation, and another one in standard crypto TLS. There were also at least 2 that were removed for other reasons. Standard FIFO linear FIFO was removed due to being poorly designed, and standard compress.flate circular buffer was removed with the compression code. A related change is the removal of BoundedArray. It was a useful structure to keep a small but only runtime known number of values on the stack by reserving space for the whole array. It is now possible to use ArrayList instead, like this. Since we're in control of the buffer, we can put it on the stack if we want. The above is possible with the so-called unmanaged ArrayList, which is the default implementation of ArrayList now, and the managed version, where the array keeps a pointer to the allocator and always owns the buffer, is renamed until it's removed in the future. As in the example with bounded array replacement, using unmanaged ArrayList is more flexible, even though it's easier to mess up with allocation. Similar to ArrayList, singly and double linked lists were also changed, so the definition is simpler, but usage is a bit harder. The old definition was obvious, but in the last patch, it was degeneralized by removing data from the node. This way we can and have to handle data by ourselves, so the list declaration changes from this to this. Accessing data is a bit harder now. We will first have to do a little trick by getting the parent structure pointer with a concrete type. The new approach doesn't look better to me, but I never use linked lists anyways. There's almost always a better data structure for the task. And finally, some small uncategorized changes in the standard library. fs-dir copy file can no longer fail with error out of memory. Honestly, I wonder what allocation they removed there. fs-dir atomic file now requires a write buffer in the options. It's kind of a result of the Writergate. Like the next changes, fs atomic file now has a file.writer field instead of file. In fs file, write file options, write file all, and write file all unseekable, they were all removed in favor of file.writer. And finally, POSIX send file was replaced by fs file reader send file. So just for a quick summary of this release in numbers, 5 months of work, 162 contributors, 647 commits, 8,679 files changed, 1,189,100 insertions, 357,646 deletions, and the most changed part was the x86-64 code gen. It's too hard to tell how many little features were added and little bugs were fixed, but my approximation based on the commit history tells that there were 80 features added, 157 bugs fixed, 29 deletions, 5 deprecations, and there were 382 commits that were unclassified. Whew, and there we go. That's it for today. If you want to, you can subscribe to my channel. I'm Tokisuno. And yeah, subscribe to this channel to fill your recommendations with similar content, and I will see you in the next video.